brain-computer interface isn't the next stent, it's the next internet.
Most VCs and MBAs want to see what is the existing market. Either that's really big or it's really small. I see a market that doesn't yet exist, really. And I say, I'd rather take a massive chunk of a brand new market.
It's also that classic trolley car problem. Like, a lot of people would feel uncomfortable pulling the switch to route a train, whereas doing nothing feels like a moral pass. I would argue that Austin is the neurotech capital of the world right now.
Austin will go through kind of a rebirth.
Most advanced technology in the world, and if you can't actually build it or ship it, then what's the point?
You need storytellers who are able to paint the picture of what's happening at the frontiers of technology.
The U.S. needs to get back more to that and less like lawyerish and more we're building stuff.
The frontier isn't just a place, it's forged in the fire. Welcome to Austin Next.
Connor, Matt, welcome to Austin Next.
Thanks for having us.
Thanks.
I think this will be a fun conversation about the brain, technology.
And Austin.
The term neurotech, because it's thrown around, used a lot. How do you guys define it? How broadly do you think about it? I mean, we talk about, is it just things like BCI, or is it all the way from like mental health apps and software? Like, how broadly do you want to define it? And what is it?
You want me to go first?
Yeah, you go first.
I mean, so I'm probably the most controversial one, parading as neurotech, right? Because we actually use electrical activity from muscles rather than from the brain or the quote unquote nervous system. Now, to me, neurotech is really anything that takes electrical activity from the body, which all originates in the brain and then goes downstream to different places, and either using that electrical activity to communicate or do something with a machine, or to try to modulate the electrical activity and therefore what's going to the brain in the body, so bidirectionally.
Would you consider then a pacemaker based on that definition?
So technically I would, yeah, right? So I mean, it's at the end of the day, that's modulating like the body's inherent neural activity or electrical activity in order to do something. So absolutely, like, gastric stimulators, pelvic nerve stimulators, all of these things that are affecting the viscera or the organs of the body in some form or fashion, I would classify as neurotech personally.
We're going to draw the line then on the electrical activity. So if it's something, when we think about like mental health or software diagnostic, like those type of tools, for your definition, you're putting that outside.
I would. I mean, you might put me into a pigeonhole here where I'm contradicting myself, but because I haven't thought about it super deeply, but I would say, yeah, something externally looking at, I guess, your body movements or like motion tracking or something, I wouldn't consider neurotech. Mm-hmm. I would say something that is like physically getting the electrical activity from your body, either non-invasively from the surface of the body or invasively from within the body, or trying to modulate it either from the surface of the body or within the body. Okay. That's what I would classify as neurotech.
I think like neurotech, lowercase n, is a pretty big tent. It can be anything that's getting brain signals or interacting with the peripheral nervous system. It could be focused ultrasound as neurotech. Mm-hmm. It's a lot of things. I wouldn't want to like draw boundaries. I would say though that like the neurotech movement that's happening right now, which is like really emphasizing the tech aspect, has been this group of startups that are taking a more like data-rich approach to the brain and kind of signaling in the body. And I think I would distinguish that from, if you look at kind of like systems neuroscientists that were like working with the brain a decade ago, 20 years ago, like doing DBS, they have these like block diagrams of how the brain works. And it always reminds me of, there's a kid's song, like the head bone's connected to the neck bone, the neck bone's connected to the collarbone, but everybody knows that that's ridiculous. They're like, those aren't the real, like, that's not the right taxonomy for like the body. And I think like these systems things where you show like blocks of things connected and like, oh, we're stimulating in this area. And you're like, well, that's like 5 million neurons that you're stimulating at once. Like there's been this movement in my mind from really kind of like clinical kind of like immature view of like the brain and interacting with the nervous system to a more data rich system where you're like, okay, well, we're going to collect electrical activity from the muscles and we're going to build the most efficient decoder to control a prosthetic arm. Or we're going to go record from hundreds of thousands of neurons and try to predict what someone's trying to say. We're going to, like, there's this kind of leveraging sophisticated machine learning approaches to get as much out of the data as possible with an emphasis on the data rather than like kind of, I don't know, kind of cartoony drawing understanding of neuro.
So is this, I mean, taking like deep brain stimulation has been around for a little bit, and are we seeing the shift and inflection point that's happening now because of a technical breakthrough, or is it a methodology, like they're taking more data, or they understanding, like what's causing this shift that's happening right now?
If I think of in brain-computer interfaces, one that's capital, better hardware platforms being developed, but also from a data perspective, 25 years ago, the kinds of computers that you needed to use to run decoders and the kinds of machine learning approaches you had to do decoding from large populations of neurons was immature. And now we're drafting behind, $1 trillion+ of investment into edge compute and to AI. And so we have just this embarrassment of riches on the data side that we can tap into.
Whenever somebody asks me like the why now, why are we starting to see all this? I think really it comes down to three things in my mind. The first one is really with DARPA at the helm, funding an unbelievable amount of research, basic science research over, a decade plus, probably 2 decades time, of trying to augment the nervous system, primarily in the setting of some kind of disability, which answered a lot of the fundamental questions of like how you go about creating these technologies and creating, I guess, AI architectures that can decode the electrical activity or send the electrical activity back into the body. So we're just now entering the period, or over the past maybe 5 years, have just entered the period in my mind where the basic science has hit the point for where it's now ready for commercialization, where it's no longer a bunch of feasibility stuff. It's about how do you package that commercially into something, which creates another order of magnitude problem, which is like, how do you commercialize these things? And in order to have a successful medical product like this, you have to have the ability to do edge compute. You have to have low power electronics. You have to have certain technologies that can go into the form factor that's required for like a scalable commercial product that have just now started to come into a commercial setting in order to do that. And then 3 is I think that, obviously with Elon and Neuralink and the public persona that's come to be with Neurotech, that's created this impression that everything's just now happening, whereas there was a lot going on behind the scenes before it really became mainstream through this key individual getting involved in the field.
I agree with you that the clinical existence proofs are essential. It's very hard for funders, for investors to kind of get behind a movement until they've seen end-to-end application. And so whereas, let's say through various research programs, like our understanding of the brain, how things work, it's been maturing over the last 20 years. It's really been now these clinical demonstrations where someone actually gets a really meaningful benefit,
right?
That says like, okay, now it's ready.
For sure.
When I think about the DARPA funding, and this is like an N of 1 situation, I remember meeting somebody and they were like, yeah, I got funding for some prosthetic, study. And then it's like, okay, so then what happens when this is over? Oh, I'm going to apply for another grant. And it was this constant cyclical nature of just like, I'm chasing the grant. I'm like, so when does the leg or arm, I forget the case in this, but actually get out there and
it takes someone crazy like the two of us, right? So much amazing advancement is left on the shelves of academia because it is just this cycle of tenured professors or students or whoever it might be doing research so they can publish, so they can get more money and move on to the next thing. And so once they answer a question, that they got grant funding to answer, they check the box, complete, onto the next. They don't give a shit about if it actually has like a scaled impact on society or anything. That's not their job.
Or maybe they do give a shit about it, but there's just no one to pick it up from there. I mean, we know from the time we started our companies and we were like, oh yeah, everything's been demonstrated, we're ready to go. Like from the time that someone did a thing.
You have to be a certain level of naive to be an entrepreneur.
Totally.
From the time you did it once and you showed it was possible to the time you can do it repeatedly all the time in a commercially viable way, that's where really most of the work is. That's why electric cars stalled as long as they did before there could be an electric car industry. Like
I'll push on that because I always love the who killed the EV1 and this big conspiracy. It was a terrible car. Like, you have to be able to create something that you want.
Sure.
Create, you know, I mean, in this case, in our
we're saying the same thing.
Yeah.
I think the point is that they existed in concept, but to bring it to market in a viable way was a shitload of work.
Right. So I always say, like, the success of a company is maybe 10% the technology and 90% everything else. So for like EV1, right? Well, if it's not in the right form factor, or it's not sexy enough for the general population to like it, like, it's not whether or not like it's a viable concept technologically. It's about all the other stuff that goes along with it that leads to like market adoption, which usually is irrational.
If you take valuations to be a measure of value, which is probably not totally right. Like, just look
You're
at
measuring
like,
something.
the best the best academic spinouts, you know, coming from MIT or Johns Hopkins or Stanford or whatever. They come out and they're raising money at, you know, $2 million pre-money. That's what the idea was worth. That seed valuation, that was the idea. Mm-hmm. Then, like, look at the real milestones that actually lead to higher valuations. They tend to be, you know, okay, now we have regulatory approval. Now we've demonstrated, you know, we've exited our pivotal trial. Now we have sales. Now we're cash flow break even. That's like tends to be.
So I want to go back to what you said though, with the three pillars, and that DARPA being one of them in this. But then we see these cycles occurring. So is there a particular thing that was funded by DARPA that, like, okay, that changed it? We have a better understanding of something now. We have better technology, some underlying, because again, it's this, the valley of death with the translation, which, to your point, like, requires almost different people than who are actually the ones going after the grants.
Right. So, you know, where DARPA was very impactful for Phantom, I would say, or the position that I was in, was that DARPA does like just basic fundamental science feasibility research. And they usually cast a pretty wide net in the approaches that they fund. They don't just fund one approach, they'll fund 5 different approaches and just see what happens. And so they funded research that was, you know, implantable brain, you know, recording electronics, wearable EEG stuff, spinal cord, peripheral nerve, muscle, wearable EMG, you name it, all of it. They funded research focused on all those different approaches. And so then I was able to, along with like my collaborators and everybody, kind of sit back and say, okay, let's look at the broad research that was done and let's look at the use cases that we're trying to target. What seems to be the most scalable and highest efficacy approach, and the combination of the two, in order to go and solve these specific problems, right? DARPA really provided the fundamental layer of research that allows someone to come and like evaluate things without having to invest $1 billion of their own money to do that kind of feasibility research. So that's really the power of DARPA in my mind, is funding a ton of stuff that then innovators can come and kind of pick up the right pieces and then move those specific pieces forward.
Our company wouldn't exist without DARPA funding. We were at a point where we were a concept and we had to do hardware build out to demonstrate the core technology. NIH won't pay for that kind of thing. They don't like to do device development. They like to do hypothesis exploration or clinical trials with a device that exists. So who's going to come in and build something speculatively? Investors don't want to build something to see if it could work. And so, yeah, that it has a very important place in the ecosystem. And I would say, I don't even know if Neurotech, as we're talking about it right now, could have existed.
It would not exist in the world, I don't believe, without that, right? America is still the best place to do fundamental research. So DARPA funds this fundamental research, and then that spreads its tentacles out into all over the world. And because the researchers that are actually doing the research within academia are not just Americans, right? There's a bunch of people, and then they go back to their countries and, you know, it propagates out.
By the way, that is a place where the U.S. is still leading significantly. Neurotech is a place that the U.S. is pretty far ahead, I would say, of the next closest country.
Right. I would agree. Now, I would say that gap can quickly be shut out because of the barriers, for better or for worse, the barriers to clinical trials in the United States, and how freaking hard it is to be able to do research, human research that is, in the United States, that other countries don't have those same barriers.
Well, and especially when you don't have the other barriers, and then the nature of what we are doing is starting to change so much. So I know it's not in neurotech, but like there was the example recently of a baby cured of a disease with using CRISPR, made all the news, N of 1, it was fantastic. I'm like, okay, what's the regulatory path for that? How do you do an N of 1? And we should be able to do that. But that becomes, we go back to viewing rather than doing this singular, like, here's the widget, right? Like our structures, here's my widget, you prove it for X. I want to change it at all? Okay, got to start all the way over again, right? Versus whether it be the process for like software startups or whether it be platform plays, like, yeah, you can go in this way and that way and this type of thing. But our entire structure has to change now to keep up with just the technological improvements that are happening.
And I don't know that we are very good at adjusting our regulatory systems.
Part of it is a
for innovation.
societal decision to absorb more risk. I mean, we can't ask regulators to, hey, we want you to promote innovation, get as many devices out there as possible, streamline things for companies, and then we never praise regulators when they approve something, but we're quick to accuse them of being asleep at the wheel when anything bad happens. Like, we as a society would have to adjust to, we're going to move faster, we're going to cure more diseases, and sometimes we're going to get it wrong, and people will be hurt during clinical trials, but we have to offset that with all of the benefit that we'd provide. I think if we remain risk intolerant as a society, how could we expect regulators to behave any differently?
We always have the mentality of, these new things have to be perfect rather than understanding all these people are being injured or hurt because it doesn't exist. Like, you see like the self-driving cars or whatever, they're like, oh, we're gonna this is bad because it had an accident. Like, how many accidents happen a day because people drive it?
The U.S. is like disproportionately focuses on adverse events, not just medical, but like you're talking about with like autonomous cars, right?
It's also that classic trolley car problem. Like, a lot of people would feel uncomfortable pulling the switch to route a train that was going to hit 10 people to hit one person instead, because they feel responsible for hitting that one person, whereas doing nothing feels like a moral pass. And that is exactly what you're doing when you start greenlighting more clinical trials. You're going to, on average, help more people, but there will be some people who get bad devices or get bad drugs. And so it feels like an action that you're taking rather than no action, which seems less morally culpable.
But even in the clinical trial, there's a reason somebody goes into a clinical trial. It's not like, okay, my options are either live with a disability in the case of like they'll have the Neurotech, or live with a disease because nothing's working. But you're right, there's a risk of going in. Okay, so, and we have informed consent and all of that. I mean, I think about Dan Wang's book, the China versus U.S. and like their more engineering culture, and to the extreme that because they think they can engineer society, and that is an issue. But we are way too much of a lawyerly culture, and it's always what's the bad I'm going to prevent the bad outcome that we can see versus what's enabling the good outcome. And especially I think in the medical world, that has led to, here's a 10% improvement, here's a 10% improvement.
Our experience interacting with the FDA has been, like, in our particular division of FDA, OHD5, which I can't speak to other groups, but like many of them trained in the same labs as we did as PhD students. They want to see devices go to market, and they're trying, I legitimately think they're trying hard to make things happen, but fundamentally they're bound by statute and they're bound by administrative mandates. And so it's like, they can't change things unilaterally, and it has to be a societal decision to make changes. Much of it's statutory, so even from administration to administration, it's not even like, oh, okay, like Trump's in, he's just going to get rid of it all regulation. No, that isn't the case. So I think I feel like it's...
No, I think the regulators are on the same page as us completely. I mean, for example, I think you got this too, like breakthrough designation and this TAP program and all these things. So like, we interact with the FDA a lot at our company. And the regulators absolutely want to see these technologies like get to market. And, one thing that we've elected to do as a company is that we're going to Australia for our first clinical trial, because you can just go there a lot faster and cheaper. And there's all these incentives to go do that. And then the FDA accepts that data as valid input data for, certain submissions that you can do with them. So, I give the FDA credit for something like that, where they allow external outside of U.S. data to be fed into FDA submissions, because they also recognize that you can go do things faster in other places, and that for a company it makes sense to do that. And so, that's something positive that they've...
Since you both are kind of at the point of starting to run trials, I think it's a good to start with, like, okay, what is Phantom Neuro? What is Paradromics?
Oh, yeah, we forgot that part.
Let's just get right into it, right? But then also explain, like, so what what is it that you are looking for in the trial? And from your perspective, I just, Eli Lilly's CEO was just on Cheeky Pint and talking about just the ridiculous costs of trials. So what made you go to Australia specifically? What was it the cost here that's actually a barrier?
Phantom Neuro is creating a control system for people with limb disabilities to be able to control things like robotic prosthetic limbs. So we're starting with the initial indication of use for upper limb prosthetics, robotic upper limb prosthetics. And so we've created a subcutaneous, meaning under the skin, implant that goes under your skin in your residual limb or your injured limb that records electrical activity from your muscles. So every time you move your fingers, your muscles kind of flex and expand. Every time they do that, they generate electricity just like your brain does. And so you can apply artificial intelligence to decode that electrical activity into what you're trying to do. So an amputee, for example, tries to move their phantom appendage that's no longer there and their muscles still move, and then we decode that activity and tell a robotic hand and wrist to do what it is that they're trying to do. So functionally, it operates just like an intact limb. And so we're doing our first clinical trial next year. And again, like I said, we elected to go to Australia. And a lot of that has to do with how much preclinical testing you have to do to either do an early feasibility trial in the US versus an early feasibility trial in Australia. And it's that preclinical testing that's extremely expensive and can take a really, really long time. And so Australia, in our opinion, takes a much more common sense approach to it to say, okay, what do you really need to demonstrate in order to show that this is safe and worth putting in a human in order to, do an early exploratory trial? Whereas with the FDA, it can be much more prescriptive, where it's like, here are the list of preclinical testing that you have to do regardless of what you are and regardless of how much time. There's not much common sense applied to it. And so we can go to Australia.
It's process driven rather than outcome driven.
Right, exactly. And with Australia, it really is a case by case where there's like a local IRB board, a board of people that approve research studies that look at it together and then make that determination, rather than going to like the central FDA equivalent in Australia and having them do that. So you can ultimately go much faster. But then also Australia offers like a tax incentive for people to come and do research studies there, where they give you a lot of money back for R&D dollars spent. So you can move faster, you can save a ton of money doing it, and then you can take that data and feed it into the FDA to get approval for US clinical trials or for US submissions. And so that's really what we've locked in on. And so a lot of it really is just preclinical testing that is so burdensome when you're trying to do a clinical trial.
I want to dig into Phantom for a second. My understanding, and obviously you'll know it better, is the penetration of actual like robotic limbs is very, very low. They're great and awesome. There's some companies out there doing amazing things, but due to cost, there are all these issues with them. So how do you deal with that kind of barrier in that I don't know if you are catalyzing them or you're having to wait for their penetration to go.
So one of the reasons that we chose upper limb prosthetics as our first market is there are a ton of robotic upper limbs on the market, whereas for lower limb, there's almost none commercially available, that is. And so a piece of robotic technology is only as good as the control systems that you can feed into it to make it useful. A really cool $75,000 robot limb sitting on a desk is of no use to somebody. A really cool $75,000 robotic limb where you have like one or two buttons to press to control all these crazy functions is not of use to a patient. And so that's kind of the ecosystem that we exist in today, is where there are horrible control systems for incredible pieces of technology. What you want to do is create a control system, an interface to take neural activity or muscle activity, whatever you want to classify it as, and transmit that high bandwidth data into a machine to do high bandwidth functions with it. And so that's really what these human machine interfaces are focused on, is how do you take these incredible machines that already exist and just give them really good control inputs and a lot of them so they can become functional to a patient. Because today, when you have two buttons to control 20 different actions, it's a very burdensome process, and most people end up ultimately abandoning that technology because it's just not worth the effort relative to other solutions. So payers say, why the hell am I going to pay $1,000 for this limb that I statistically know that you're going to abandon to go to this much cheaper solution? I'm going to go ahead and give you that cheaper solution, and then let's wait and see what happens with the ecosystem.
Do you bring down the cost of the limbs because you can start saying, hey, you can outsource whatever you want to say more to the controller versus the limb itself?
Not immediately, but when you start to get really good outcomes with patients, then the economies of scale can take place. So once limb providers are selling a lot of limbs, now they have the financial incentive to make them cheaper, lighter weight, more cost effective, all of those things. But when they're only selling a handful of limbs, they have to sell them for a really, really high price for each one because that's their whole business.
This is why you need startups, by the way, because an MBA would look at this and they'd be like, arms don't get reimbursed well, like there's no business here. But Connor looked at it and I think correctly identified, yeah, of course, if the $75,000 hand is no better than a hook, people are going to pay hook prices. That's because CMS, that's usually setting the pace for all the private payers, is saying, is it reasonable and is it necessary? Necessary? Absolutely. If you don't have a fucking arm, you need a new arm. Reasonable, $75,000 expensive robot arm that doesn't do anything is not reasonable, but a $75,000 robot arm that is like Luke Skywalker's hand, very reasonable. So I think you have to change your thinking, and a lot of people aren't used to that.
To me, this is one of the superpowers of a neurotech founder, which is most VCs and MBAs and people like that want to see what is the existing market, what's the size of the TAM, total existing market, and either that's really big or it's really small, and that determines whether or not somebody's going to invest in it. Whereas I think about it, and you probably are the same way, I see a market that doesn't yet exist, really, and I say I'd rather take a massive chunk of a brand new market, right, and totally dominate that market rather than go into this massive TAM and try to take my tiny little sliver and compete with all these other people.
Everybody talks about unmet medical need. They're like, oh, I want to invest in unmet medical needs, but what's the existing market size?
Well, in fact, it's the Uber scenario, right? The market was not taxi cabs, right?
That's right.
And I think one of the things that's really beginning to hit, I think, our industry more is, it used to be, you said it was like, here's this unmet need, but it's like if you have 1,000x improvement in the technology, it doesn't fit nicely into the system. You have to think about, how am I building a new business? How am I building, something for a market that doesn't exist? I mean, and I recommend everybody who's interested in bio, go back to listen to the Eli Lilly CEO on Cheeky Pint. What was shocking to me, so they did $40 billion last year in GLP-1s. The highest group that was paying was cash pay. Like, the entire nature is, and because it's actually having market forces, instead of seeing classic 10% improvements in the price or increase in the price every year, GLP-1 prices are crashing. Like, Novo has to survive, and the only way to go against it. And so
imagine trying to estimate like the market size for antibiotics, like when they were first coming out. You were like, well, like the competitive products are coffins.
Right, exactly. But, it takes visionaries.
Well, it's funny because I think I brought up antibiotics as we don't have next-gen antibiotics because it's a business model problem. Because if I go and create the next great antibiotic, your first reaction of a doctor is to put it as the 10th line of defense because we're worried about antibiotic resistance. And so that makes perfect sense, and it's a logical move. But if I'm paid on usage of the drug and you're saying I'm never going to use it, why would I ever make a new one? And
that's why I say that, like, the success of a business is 10%, the actual product itself.
Yes.
It's everything else. So if you don't understand the entire medical ecosystem and every stakeholder that's going to be touching your product and what causes them to either elect to use a product or not use a product, you're dead in the water if you're not considering those things, regardless of how good your technology is.
It's understanding the way the system currently works as well, and the hinge points to completely change it.
Correct. Right?
Because look, if I've got a 20% better medical device, then good, great. I'll go the regular FDA path, get reimbursement, rip out the old one, put in the new. But in these situations you're talking about, where like, entirely new markets, and we can get to like BCIs, like you have to think differently and say like, okay, maybe pricing maybe it's consumer, maybe not for some of these things, maybe not be consumer, but like how we think about the business of health starts to radically change.
Completely. Well, also I would say that we have the unfortunate issue of technically being a medical device, right? And the medical device world is really challenging economically, right? Because it's centered around like the next semi-better catheter.
Right.
That's the business model that everybody's familiar with. What we're talking about with these human-machine interfaces is like a radical change in technology that should not at all be compared to like the next iteration of a catheter. And so that's something that we struggle with, or at least that I do, is for investors to recognize that like this has potential, even though it is quote unquote a medical device, it has potential to be something that is more of a tech outcome, a generalized tech than it is.
Like a brain computer interface isn't the next stent, it's the next internet.
Right.
That's right.
So
that's right. That's exactly right.
And it creates, I mean, look, we saw in tech, to your point, it wasn't like just the technical improvement. It wasn't cloud computing that changed everything. It was cloud computing and SaaS. We figured out the business models. We figured out the new platforms that end up happening. And I think like, BCI is a great example of that, because we talk about obviously the direct medical applications, and they're the questions of what happened, like when it's not a medical application, when it becomes something else.
Brain-computer interfaces are data interfaces between brains and computers. They allow you to take thoughts and intended actions from a brain and turn it into something sort of external on a computer, like moving a robotic arm or allowing someone to speak again, which is our first clinical trial. Someone like Stephen Hawking, who lost their voice due to ALS, allowing them to speak through a computer. But it can also read out things like mood. You can run the process in reverse, and you could take an image from a camera and put it into someone's primary visual cortex. You can take a sound and put it into their auditory cortex. And so this is, I mean, it's more of a modem is the right way to think of it. And like what's interesting from my perspective about brain-computer interfaces is that we're going about building this next platform for human technology integration. And unlike so many trends in tech, where like the side effects are all negative, in this particular case, the side effects are very, very positive, because in the pursuit of building Sam Altman's ultimate, AI merge VR machine, we're going to cure blindness. We're going to cure deafness functionally by providing a device that can provide that interface, giving someone the ability to control robotics. I mean, you can look at it for functional restoration standpoint. I mean, but the same thing that would allow someone to control like an Aptronic robot here in town and provide them mobility even when they're completely paralyzed, you can start thinking of crazy stuff like it doesn't even need to be in the same city as you.
Right.
You could have 10 of them. And so you could have one in Paris, you could have one in Rome, one in Athens, and kind of switch between them like flicking through tabs on a computer. Yeah, the same platform infrastructure that's being built for these futuristic applications is the one that will be brought into the clinic to meet meaningful unmet medical conditions. And so whether you want to think about it as an investor or as employee, as a medical platform or as like the next wave of tech integration, it's the same hardware that you're building.
I think that's the key, is like you can do radically different things with our technologies as a whole with the exact same hardware design and general algorithms and all of that, right? Which is very unique to be able to do that. For us, you implant something under the skin and you can, control a robotic prosthetic limb, you can control a mouse cursor, you can fly a drone, you can do all these different things using the exact same hardware platform. And I always liken it kind of to a new version of the iPhone, right? Where we never could have perceived how important the iPhone would become in our everyday lives and how it would be our central hub for literally everything that we do. The same thing I believe is going to happen for human-machine interfaces. First, it will be people with unmet medical needs, but then eventually, over a long enough period of time, it can be an elective type of technology.
And I think the challenge for us is to build products that are so safe and so wondrous that everyone wants them, even beyond medical applications. And I think like in building something that someone that doesn't have a disability would want, we're also building really high quality products for patients.
How do you not get stuck in so I'm just going to do this medical application? Like when you think about these things as platforms, but the tension in the healthcare world is really more asset driven, right? And so like, here's this widget, here's this asset, here's this drug. How do you keep building upon it as thinking like as a more classic, as you said, like tech entrepreneur and building these platform plays while not everything that we're doing in these cases, it's not as, I mean, there may be software components to it that are faster iterated, but these are not fast things to change.
For us, it's talking about the future opportunities and then demonstrating some of those. So one cool thing that I think Neuralink has done with their initial cohort of patients is that they've, had them play video games and do, fly an RC airplane and do other things. So they're demonstrating like, look, the same technology can be used for these vastly different use cases. And it really wonders the mind about what the possibilities might be with this. So showing that there are these other opportunities. Whereas if all they demonstrated, but was the same use case, for somebody with spinal cord injury or whatever it might be, over and over and over again, people are like, oh, okay, this is like the spinal cord injury prosthesis for them to move a mouse cursor. But instead it's like, oh man, they can do a whole lot of things.
So much of this innovation happens in the application layer, the software that runs on top of the medical device. We're going to be innovating in that area anyway for the betterment of patients. But let's take, for instance, a visual prosthetic. Like if you had a 20/20 visual prosthetic to restore your vision, why wouldn't you layer on things like Google Lens? Like why wouldn't you have that capability to immediately identify things in your world? All of those things you get for free. And so definitely there will be people who have vision and look and they say like, wow, that's really cool. That's basically a superpower. I'm interested in that. And I think that's how it will happen, is that people with disabilities will get restorative technologies and will have superpowers. And then people who don't have that disability will look at it and say, that's really interesting to me.
The example that I always give is breast augmentation in my world, right? I come from a plastics world, so that's common there. Breast augmentation originally was designed following mastectomy, right? For reconstructive purposes after a mastectomy where there's a clear medical need and way to get it reimbursed and all that. It doesn't take long for people to see that and be like, well, I don't need a mastectomy, but I still want that.
Right.
That's a superhuman type thing. And then we all know where that's led.
And plastic surgery is actually a great example, because if there weren't cosmetic plastic surgery for non-medical use, there wouldn't have been so much money coming into the field, and it wouldn't have matured so that now if you're in a car accident, like your craniofacial surgery and your restorative surgery is going to be better as a result of the amount of money that's come into plastic surgery for cosmetic purposes. And so like it is a flywheel. And so I think it isn't just going from one direction, like from medical to consumer, consumer to medical. It's a cycle.
We see like LASIK is another one, which has come down drastically. When you actually have market forces being at play here, amazing things start to happen.
It's all the economy of scale. And, it takes the vision to be able to see where that comes into play and, have the wherewithal to be in it for the long run to get there. But that's where you can start to have a really massive payoff.
Where we're seeing a change now, though, is that, 5 years ago, it was like we were like lone voices crying in the wilderness that this thing is coming. Now you see like major VCs and major capital sources coming in with this thesis and backing it. And so it's taking off significantly.
So are you seeing from the capital structure, is it the traditional bio and health VCs? Is it the very traditional tech, or is it kind of almost a new group that's coming out that sees an intersection and kind of sees things differently? Or all the above?
From my experience, I think it's the quote unquote deep tech investors are the ones that have a lot of interest. We absolutely do have some like stereotypical healthcare investors who lean towards the deep tech part. Like the classic middle of the road healthcare investors are not interested, at least not yet. They will be one day. But it takes the people that are forward thinking, that are willing to, take a risk on things.
Groups that traditionally invest in medical device have already like missed it, basically. Like a lot of them don't have like huge funds, and they're like used to pricing according to medical device prices. So by the time that they are like getting comfortable with it, it'll be like, fine, you can buy in at like $5 billion.
Well, because the traditional medical device don't ever hit that, right? Yeah. Like you put in 10, 30, 50 million, have an exit to Medtronic or whoever for like
it's
500 million.
It's self-fulfilling. If you only ever invest in like marginal improvements to a urinary catheter, then you're never hitting those big numbers, except for the couple of people who backed Intuitive,
But even Intuitive, which is, I think, the perfect example, it created a platform. It was not a better scalpel. It was, how do we think about robotic surgery? How do we democratize it? It's funny, I think about where healthcare is going with AI and creating like superpowered doctors. And for a long time, I kept saying like, well, I think we're gonna get rid of specialties. I think that the idea of there being an oncologist, a cardiologist, if the doctor has Dr. AI on their shoulder, why wouldn't they be able to do all of these different things and be able to understand that? And I always I'm like, well, surgery's over here though, because surgery is its own thing and everything. But like, if you take Intuitive to its logical conclusion, forget the completely replaces the surgeon, but just any doctor can do surgery then, as long as you have the robot able to help you there. So, and you have that, or like Illumina is another example, right? Where you had this, it's an entirely new platform technology.
Most neurotech companies are platforms because they have like a formative hardware capability, and then there's so many different software layers you can put on top.
That's why I view us more as a tech or software company, right? I mean, the hard part is getting the hardware right. That's a really, really challenging thing to do. But once you nail that, it becomes a software company where you're just changing your API or a little bit of your algorithm in order to do these vastly different use cases. And so that's how it really scales. Whereas with every other traditional medical device, you have to build an entirely new physical product to do those different things. For us, we can spin up a new application in a matter of days or weeks, right? With minimal resources. So it starts to look a lot more like a software company.
Do you see the difference? And obviously you guys came out of academia in different ways, but the entrepreneurial aspect and the ability to tell stories. But I think one of the things that we've seen historically is it was very science driven. I mean, the amount of presentations I've been into for like startups and bio, it's like, here's all my data. That's all I'm going to tell you, like this. Even to the point, it always drives me crazy. Like if you put up a graph, at least tell me is high good or low. Like you're just like, here's my graph. This is awesome. I'm like, okay, why? I don't know this particular space. But I think that we're now in this kind of moment of, I'm not just talking about the science, but I'm painting a picture. We're building the future.
A lot of academics operate in a high context environment. Like, like Doc Brown like hits his head and is like, flux capacitor. For him and all of his friends, like as soon as he said flux capacitor, like the time travel DeLorean was obvious. And so like many people just, they come from this high context environment where everyone understands what they did is important and they only have to like, show the graph, like look at my energy density and my new battery and everyone will be like, but obviously VCs are busy, investors look at a lot of different deals and they're low context individuals. And so in order to translate the importance of the flux capacitor, or I just quadrupled the amount of energy that you can put in a battery, therefore that will revolutionize all of the automotive industry. You just have to like connect those dots for people. And I think that's where a lot of academic founders need to like just say the quiet part out loud. Like, how is this changing the world? Like,
I think that within academia, like you're surrounded by other experts and you speak your specific language to those people all day, every day. And so I remember when I first started, I was pitching Y Combinator and I started going deep into like complex neuromuscular reconstructive surgery and like axonal growth factors that are released, when you cut a nerve and this and that, and all their eyes glazed over and of course didn't get it. Thank God I didn't get Y Combinator. I'm super glad that I didn't in the long run. But I learned over time that I had to really get out of this academic mindset and just really simplify things, for an 8th grade level, literally. Because I mean, most people don't even know that muscles generate electrical activity, much less all the other stuff that goes along with it. And so, and that's not on these people that I'm pitching to. Like, why would they know any of that?
Right.
So I had to get off my high horse as like an academic mindset, thinking everybody should know all these scientific principles. I would say, look, these people have not had the training that I've had. They don't have the context. Like, what is the basic thing that's going to happen here? And like, how is it going to impact society and make $1 gajillion for these people?
For me, one of the things was communicating the importance of data rates. Like, it was intuitively clear to me that if you build a higher data rate brain implant, it will just blow open the application space. Data rates it's just not an intuitive thing for most people. And so, but as a good example that I found that actually helps most people get there is just thinking about the internet. I said, like, think about what you used the internet for in the early 90s. Then like, think about what you were using it for by the 2000s. Like, as soon as we remember watching pictures load line by line. It was tedious. And the internet was not a visually rich environment at that time. 2010, enough people had enough download speed that Netflix did a pivot. They said, we're not mailing DVDs anymore. We're a streaming company. It wasn't a brilliant idea. James Bond had, streaming video on his watch in the 60s. Everyone knew that was a thing, but it wasn't enabled until you had enough data. And so I have found that you sometimes having a sort of entry point that is more intuitive, like the internet, can help people start to imagine what the world of BCI could look like. Cause then they think oh shit, the device that's enabling all the YouTube videos that you see online with BCIs, except for the Neuralink ones, invented in 1989. So my technology has been arrested in the late 80s, early 90s, and all the videos that you see online today were technical peers of internet in the early 90s. And where the internet took off at exponential rates, BCI kind of arrested until present day, when high data rate BCI is now taking off. And so we're gonna see this time delayed expansion of applications in BCI that will exactly mirror what happened with the internet.
I'm curious, I know we already touched on this maybe a little bit, but in this context, what do you think caused it to finally take off? Because you're exactly right. The actual, a lot of the hardware and the source of extracting the signals has been in existence for a very long time.
I think it could have happened potentially 10 years earlier than it did.
Yeah.
I think it couldn't have happened much earlier than 10 years earlier, because we do rely today on high performance compute NVIDIA, basically, and a lot of machine learning algorithms that have been developed over the last decade. But could we have done this earlier? I think we could have if there had been people willing to take risks and put the kind of capital on the line, the hundreds of millions of dollars that are flowing into the BCI space now. I think it actually could have happened earlier, which is frustrating for people living with ALS right now.
Absolutely.
Well, it's an interesting, and I think I want to bring up YC and then get it to Austin, because I think there are first principles to ecosystems and how they thought. There's this great, like Lenny's podcast. They put together this data on YC based on sector. And it's really telling because the amount of investment and the returns for enterprise, consumer, and fintech, off the charts. Industrials, bio, prop tech, no. And you look at that and say, like, so you said, like, you were happy to get into YC. And it's like, this not any sort of knock on YC. And they're making some of the pivot now into more hard tech. We'll see. History says that they don't know necessarily how to do that. And so it makes sense to be where, where the environment works. Like I literally just this morning, A16Z put out a piece that I very much disagree with. That was basically like, there used to be all this stuff about like local ecosystems and they were thriving, but now because of AI, it's SF or nothing. It's like, no, and you guys keep also investing in stuff here too. So that's a whole other thing. But so the question is, why Austin? What brought you guys here? What do you think of the ecosystem, especially when it comes to things like neurotech?
I'll say a lot of my reasoning is because of guys like this, that were already here, and this ecosystem in neurotechnology in particular that was starting to form here in Texas. Now, whether or not like the impact of that ecosystem has been monumental on us or not is another conversation, I think. But there absolutely was like a perception of and a reality of all these neurotech founders and technology companies aggregating to one central place. And Austin is a very desirable place to live that, is becoming pretty expensive at this point, but still it's very easy to recruit people to come here. So I think you're surrounded by amazing people, and it's a desirable place that people want to come to.
There's only so long that people can eat ramen, and like you can't build every possible company with 19-year-olds who are willing to live on ramen for 10 years.
I think my kids will want to eat ramen forever, but
we reached a point where we had been in the Bay Area for 3 years. We spun out of Stanford, and a lot of us were having our first kid, we're getting married, we're thinking about, life stuff. We're looking at, if you want to live in a good school district in the Bay Area, you better be ready to plop down like $2 million for a house with a leak in the roof. And it's like, it's not a place where you can live very easily if you're not rich already. We were all poor. And so like that works if you have a software company and you're like, oh, my software company is called Flaglugle, and it's spelled with no vowels, and we're going to sell to Google in like 18 months. That works. Like everyone just rents a house together, you do your thing. But if you're building something transformative, you're going to have to wait a little while. You're going to have a little bit more sustainability, and you're going to have a plan to weather a decade. Left Stanford a decade ago, and now we just got IDE approval and we're starting our clinical trial early next year. There was a ton of stuff that we had to build. We had to go through a verification and validation process, all that expensive preclinical work that Connor was talking about. And like we knew that if we had to do that in the Bay Area, it was going to be very expensive. We're going to lose awesome people. And we moved to Austin because it had this like amazing balance of it was still affordable and still to some extent is if you're willing to to
compared to other places. For
I was going to say,
it's
if you're comparing to other places in Texas, maybe not so much, or the Midwest, you're comparing to New York or SF. Yeah.
Great tech ecosystem, great medical device ecosystem. People are willing to move here because it's culturally interesting. It has this feature where if you are 20 years old and you want to go to a concert every night, you can live downtown in like a 1-bedroom apartment and have a ton of fun. If you have a family and you need a little bit more balance, you need a good school district, you can live 30 or 40 minutes outside of the city and buy a house still for less than $500,000 in a really nice area.
To me, just the last note I'll make is, to me, the biggest piece was like, is this a place that you can recruit people to come or not? In neurotech in particular, it's a somewhat niche field where you have these extreme experts who may not already be located in Austin, and they're usually not. And so you have to be able to draw talent from across the United States to come somewhere, and Austin is somewhere that people are generally very excited to come.
I will say we do have a Bay Area office where we hire machine learning people. It is very hard to get machine learning people to leave the Bay Area.
Yeah, it's not to say that like Silicon Valley is dead by any means. Like
not
there's
at all.
still like it is alive and well.
If you are building
But-
an AI foundational model, get your ass to Silicon Valley. Like that doesn't make
there's
any
a big
sense.
defense tech hub, even though Austin's pretty damn good at that too now. Yeah, I think it's
I
really
think we're bigger than the SF and defense tech.
yeah.
It's us. It's us
They
and
have
the
some
gun.
big names, but
it's
yeah.
us and the gun. But the big names aren't actually. I mean, the big names aren't there. Anduril's in Southern California, and
Yeah, okay,
like,
not the Bay Area. I mean,
Yeah.
generally. Okay.
yeah.
You're right.
So no, I'll give it.
LA plus-
LA and Austin, I think, are the two big defense.
I would
tech.
argue that Austin is the neurotech capital of the world right now.
It absolutely definitively is. All the key players are in Austin or surrounding areas, right? There's a little bubble, I would say, around Austin.
So I'm glad you said it, and I agree with it. And I think that it's becoming that because of just everybody that's kind of growing, and that circle kind of keeps widening. How does it work in practice? How are you seeing? Are you seeing from the investors? Are there more investors that are doing it here? We still need to be outside. The talent, is that starting to have a flywheel? Are you seeing people trading talent? Like, what does that mean in practice outside of just we've got a lot of the biggest names that are here, and then so that is getting.
It's easy to move people to Austin, and investors never ask why I'm in Austin. So I've never had any downside to being here. And I would say that being, in town with Connor and, having a number of other founders and a number of other companies here kind of going through this process, it definitely builds the community.
Also, like UT is really making a push into robotics. A lot of it, Aptronic and other companies happening. So I think that there will start to be an even more impactful ecosystem now that all of this is really becoming real, right? I think probably for sure when you first moved here, and then when I did as well, like it was still a lot of grind and early stage stuff and like, a lot of dreams, but now it's all becoming like very real with a ton of money being pumped into these companies, and they're all centered around here. So it's fantastic being here. But I mean, we've absolutely hired local individuals, but we've hired even more people from outside of Texas. And so recruitment is still key.
What is the talent that we don't have at scale that we need?
Artificial intelligence. I mean, like that's a key one, I would say. And then like medical electronics, right? Medical grade electronics. These are some really complicated, very miniaturized systems that you're building that require people with a lot of experience, right? And so I think if you're looking to hire a bunch of like entry-level engineers and things like that, then there's probably a great ecosystem here to do that. But we're earlier stage, and every single hire really counts a ton. And so we're looking for people that have a lot of experience in these different aspects. And so a lot of those people just aren't here.
What do you think from the talent recruitment perspective? Is I've heard, especially on the AI, maybe not the AI engineers, and a lot of people are putting offices like in New York because if you're they've got more scale, but you don't have nearly the cutthroat or the SF.
Yeah. I mean, also, if you make $1 million a year, cost of living isn't one of your primary factors for deciding where to live.
So how do you think? So when I think of, so we're having some serious rocket ships happening now, whether what you say like Aptronic, Saronic, Base. When you raise $1 billion in your Series C, you can attract people. People are like, I'm going to move. I'll go for that.
We haven't raised nearly that much, and we've attracted a ton of people. Part of it is just because there are only 2 high data rate brain computer interface companies in the world, and both of them are in Austin, and we're the better one. So it's kind of easy to move people. But I think also people just want to come here. They know when you bring them out to visit, unless it's July or August, people
I
want to
understand
stay.
the concept of summering now. When I got here, you're like, oh yeah, I go to Colorado, Wyoming,
Yeah,
for the summer. I'm like, what are you talking about? 110 degrees later. Yeah, I get it,
Yeah, it's miserable. I agree. We haven't raised nearly that much money. And also we have the perspective of we don't hire for the sake of hiring. We don't grow for the sake of growing, right? We try to only hire people where it really matters and it counts. And I think if you're doing really cool stuff that people are passionate about, like that's something that we don't have a problem with, and almost certainly you guys don't have a problem with, is finding like really dedicated engineers that are super passionate about what you're doing, who aren't necessarily joining just because it's a really big paycheck. They're joining because they really want to change the world and like have a positive impact on society. So they're coming to a freaking cool city to do really cool work.
Yeah, that's another thing that defines neurotech companies is that recruiting is generally pretty easy because, yeah, if you're working on like a heart catheter and someone says like, hey, I want you to come and work on a revolutionary prosthetic that takes signals from the muscle and lets you do like dexterous hand movements, you're going to go, that sounds pretty good.
Yeah, absolutely. So I don't think any of us have a problem.
What about the convergence of sectors here? Because you mentioned robotics, and like there are probably things that you can get from that versus the traditional. You're like, oh, the catheter, I want you in. But are we seeing the ability to two things? One, are we seeing kind of the cross section of ideas, like having all these kind of different founders and all like, hey, if we have the bio guys and the robot guys and the quantum start talking.
That's another defining factor, at least for brain-computer interfaces, but I think it's probably neurotech in general, is that like it's a convergence of different disciplines. And so like I compare it to the semiconductor industry, like in the 60s and 70s. There wasn't a semiconductor industry. There were like analog engineers, there were some people doing like early digital stuff, there were materials scientists, and they were all coming together and figuring out how do you build integrated circuit chips and how do you scale it. And that's what's happening in neurotech right now. There are neuroscientists, electrical engineers, there are quality people, mechanical engineers, none of whom have ever worked together. We're not a traditional medical device company. We don't do things the way that a traditional medical device company would do it. We're also not a semiconductor company. We're also not a software company. So we're figuring it out like real time.
You're an and company.
Yeah. Yes, and.
Yes, and.
Yeah, and every employee, at least with us, really has their hands in a whole bunch of different pots, right? We don't really have anybody where it's like you are a firmware engineer, period, and you don't ever bust beyond those walls, right? Everybody is involved in all these different aspects because it's multidisciplinary and it hasn't been done before. And it kind of is a messy business going through it.
The first time you put it all together, like there aren't clean interfaces between the firmware and the hardware and the software. Everybody has to be integrative.
Yeah, it's awesome.
What do we need from an infrastructure perspective? Like, do you need wet labs? You think about manufacturing as you guys get to scale. Like, what is the kind of infrastructure that we need here to take? We are the neurotech capital of the world, but like neurotech even still is nascent, right?
There weren't many flex spaces when we first moved, places that were zoned for light industry that you could also have an office. I think I found one of the only buildings where we could manufacture, and it also had enough window space to like be a non-depressing office. And so I learned a lot about
translucent humans.
Yeah, yes. I learned a lot about management, culture, and manufacturing, by the way, because I realized I went to some of these places. There's no way the boss works here. This is terrible. So I would say wet lab is a thing. There was Lauren Dolphy at Panther Therapeutics started her cancer therapeutics outfit here in Austin, couldn't find wet lab space and rented from us for a while. Mm-hmm. And so like it's hard to find wet lab space like that, and it's also hard to find this kind of like flex space. So there's a Pegasus Park in Dallas, I think has it right. I think I would love to see a Pegasus Park here in Austin.
So you've got like grad labs from Alexandria, which is like in San Diego. You've got Pegasus Park. One of the things that I found talking to, and I think this is not just bio, but there's a lot, especially these convergent types. I don't just need an office, right? That I think there's a disconnect with the real estate environment because like, oh, well, we've got 100,000 square feet. Who needs that, right? And the people who do need that probably want to build their own.
Yeah. We have a warehouse in East Austin. You can do whatever you want with it, and that's not helpful.
Right? Yeah. Like you need 2,000 to 5,000 square feet, and then you have these streets. Well, I don't want 100 clients to do that. Somehow we figure that out with offices. Like I've never understood this. I get the fact if I've got I'd rather have one lease than 50 leases. Okay, life's tough. Like you can figure it out. But I think that, that and there also I think needs to be, or maybe like this kind of gravity point where you wouldn't say
construction. If there were one thing I wish that the Texas state government would come in and just like abolish all Austin and Travis County zoning laws and just be like, we're open for business, build whatever the hell you want. Because it's such a pain in the ass to build anything in Austin. Like if you need to do construction, it's so tedious. It's like, I could have my FDA approval before I can like knock down a wall. So if there's one thing that it was like, if there are like government officials tuning into your podcast, I would love if it were just easier to build things.
you'll notice what a lot of people build that are in Austin are actually like in the ETJ, you know, so they can get away from some of those zonings, or they're outside, or just be able to build. And it's funny because it's always where our reference point is talking about, like, you know, affordability. It is so much easier to build here, even in Austin, even with all of the things, than can you imagine doing it in like, say, California or New York?
I don't know. Sometimes Travis County feels like Santa Clara County.
That is not a comparison you want if you want to continue to build. Yeah.
Yeah, no. From my perspective, that hasn't been a massive issue. I mean, we outsource a lot of our manufacturing. It's really expensive to do like scaled manufacturing in-house, in clean rooms. Like that is you have to raise a lot of money to be able to do that. So we outsource a lot of that. So like office space hasn't been a huge thing. I think the one thing that I would like to see evolve over time in Austin is the medical community. I think that having, you know, the Dell Medical School here will over time lead to a much more vibrant kind of academic medical ecosystem in Austin. I think that that's something that Austin is not known for, its academic medical ecosystem. Most people, it'd be awesome like for your first US clinical trial, and maybe you are doing this, I don't know, but right, like Austin, UT is not the place that we think of when we're like, I wonder where we want to do our first clinical
Also
trial.
because the hospital medical system is so new, they're not quite equipped organizationally to run
That's what I'm saying.
trials.
And those things take a lot of time.
That is an advantage of working in the Bay Area, especially at like a Stanford or UCSF.
Or New York City, I mean, or on the coast in general.
But I think especially any hospitals that have worked with a lot of startups. Just that kind of flexibility of understanding, like, oh, okay, like this is not, they don't have an administration of 500 people working for them. And like, if we want them to come here and run a clinical trial, we are actually going to have to make things easy for them, because if we do it like our way, then their way will just be not coming. So
I'm afraid to ask the question then. One would think, given the surround, I agree. I think the ecosystem of Austin is amazing. It's the surround. It's like we don't have as many clinical partners. We don't have as many doctors' beds. You know,
UT is sometimes harder to work with than the University of California. I don't know why it is. I think that there's certain things that are baked in by statute to the way they operate, but UT is not super easy to work with.
My question though is Houston, TMC, like they have a lot more of that surround. One would think that, okay, great, it's nearby. We have this, but is it actually, or am I wishing it was a certain way versus it actually is?
I think it is. So Houston has a fantastic ecosystem, and there's like Houston and San Antonio have a lot of like military medicine, right? So there's a lot of Center for Intrepid and, you know, bases and things around.
Huge center of gravity, yeah.
Right, for all of that.
But are they open, and to your point, like understanding the way to work with startups?
I guess we haven't gotten deep enough in those conversations to really make a determination. I would say like when we're thinking about like a U.S. clinical trial, we're looking for like the key opinion leaders, right? So like you want somebody at the helm that like as many people as possible have heard of to be involved in the clinical trial, because that, you know, breeds confidence in what you're doing and is good for a myriad of reasons. And so I think a lot of us probably look towards the same institutions where a lot of this fundamental research is being done, and therefore there are like surgeons and physicians and different types of clinicians associated with this kind of research who are really out there in the public persona within the niche world that we live in. And a lot of that just isn't in Texas necessarily.
I think for us, it's a balance between finding the specific people, not even organizations, but people who are key opinion leaders, and then also institutional flexibility. When you're a startup, you just can't afford it. If you start running into like friction with a university, I mean, my attitude now is that we literally have 100 universities that want to be part of our clinical trials, and we can't work with all of them.
Right.
Like right now, we don't have the bandwidth. So
and if you're putting up friction, you're off
exactly.
the list.
So you're just off the list. We have optionality at this point.
I agree with that. I think that neurotech in general is such a cutting edge, sexy field that it's very rare to encounter someone who's like, nah, I don't really think we want to work with you.
Yeah.
We're in a fortunate position to where I think we can be choosy a bit about who we work with.
As Austin is now the neurotech capital of the world, and I love it, and we're going to run with that. I always like to end this with the podcast with the same question: what's next, Austin?
More.
I think that there's a lot of entities that are here in Austin who are just starting to get a lot of capital, and I think that you're going to start to see a lot more collaboration between some of these entities. So, you know, you asked a question earlier about, you know, you've got all these robotics companies, these defense companies, these neurotech companies, like Are you guys all like playing in the sandbox together and trying out each other's technology and things like that? I would say today, like there's a little bit of that, but it's not a ton of that. I think that you will start to see a ton of that because once you have the bandwidth, that's meaning time and resources, which is driven by the amount of capital put into the piggy bank. Once you have the bandwidth to be able to start exploring these collaborations in a meaningful way, and there's a huge plague, this is me getting on a little soapbox here. I think the startup world is plagued by fake partnerships and people announcing partnerships that don't actually exist, where they really are just like come together to get a little press release. I'm not talking about that. I think we're going to start to see in Austin in particular, a lot of companies actually having real partnerships to combine their technologies and explore really crazy things together. Because of course you want to go to what's convenient and local to you rather than flying to the coast to collaborate. So I think over the next 3 to 5 years, we're going to see some really interesting collaborations between different types of companies.
I also think we'd be remiss if we didn't mention Capital Factory in this discussion. When I moved to Austin in 2018, Capital Factory was doing mostly software stuff. They were kind of like the Y Combinator of Austin. But now, like 2 of their portfolio companies have landed on the moon. They're backing humanoid robots, brain-computer interfaces, robotic hands. They've completely transformed. The Army runs its like innovation center out of Capital Factory. I feel like they've been a really important force in creating this kind of new Austin ecosystem that's very hard tech, very kind of medical focused.
It seems in the way that I've seen, they've been being defined, kind of, it goes both directions, becoming more of what Austin is. You said like they were starting off as the enterprise. That was what Austin was, right? Like, and that is a long time. And I think now we are, the frame I like to use is like it's the convergence of atoms, bits, and intelligence. Neurotech's a great example.
But I don't think they're following the trend. I think that they were a causal factor in making it happen. At least for us, for sure, they've been one of the most helpful investors we've had.
I agree. I mean, where else are you going to find like actual like Defense Innovation Unit being housed in this entity in downtown Austin, right? Like that's pretty special. And so I think it has created an ecosystem of accessibility, and at least to the right people.
They're super connectors. And I mean, like, I think the other thing is they're very self-aware. They know exactly what their role is, which is, connecting people and creating space for things to happen. And so, yeah.
Which I think sums up Austin, right? Like
right.
It's an amalgamation of like humble, really cool people all like mingling together and exchanging ideas. And I think it's really a special place in Capital Factory.
And wanting to help.
And wanting to help, right? I think.
Yeah, we still have that environment where I could go to any CEO in town and say, hey, can you help me with this? And I guaranteed that they would pick up the phone and help.
Totally.
Yeah. No, I've been here 5 years and have that, and not being a CEO and have that same thing, that the openness of everybody and the want to build and just the builder mentality.
Yeah.
Yeah. It's incredible people here.
Matt, Connor, thanks for joining the podcast.
Real pleasure.